Okay, so for this next problem, we have a box that is hanging from a rope, and then there's this beam that's kind of like propping the rope up. So we're asked to find the tension in the rope and the force exerted by the pivot on the beam. And so we want the magnitude and direction. So the force exerted by the pivot on the beam would be the force that would exist here. So we're told that we have a pivot, and that gives us an indication for how we want to do the free body diagram for this piece here. So in the beginning, we introed how we would do, how we would model forces for a pivot. So this is commonly how we model pivots. So let's go on down here. So the way that we would model this pivot is we would have a normal force here, right? So it's not allowed to go into the wall, okay? I think that they call this H and V, but I think it depends on the problem. Yeah, in this case they do. So this H force, so pushing to prevent it from going into the wall. And then we also have a vertical force, right? This V force. So that just basically means that there's some sort of force that's preventing it from sliding up and down. So it means that it can't like move anywhere up or down on that wall. So we just have those two forces to pin it. Okay. All right. So now we want to find the tension in the rope. The last piece is we have, this is just connected. This is like just a rope pin connected to a wall. So it'd be like tension would be coming out, but then if we model the beam separately, we have to take the mass and separate it from as a separate piece. And then we just want all of the forces on the mass. So that's what we see here, right? We just see the beam and then we see all of the forces that are acting on the mass of that beam. Okay, so we're taking our center object with all of the forces connected to it to solve. Okay, and our main goal is to figure out the force exerted by the pivot on the beam. So we want to find this V and H force. And so if we want the magnitude and direction, we should think about H and V as a vector X and Y direction. And so if we want the net force, the magnitude, V squared plus H squared would be the magnitude. And then the direction would be that polar angle for that. And that equation to find the polar angle would be it would be equal to tangent -1 of V over H. Okay, so this is the end result that we want. So to get that end result, to get the magnitude and direction of the pivot force on the bottom, we're going to need to solve for H and V. Okay, so approaching our statics problems, we're going to go through sum of forces in the X, sum of forces in the Y, and sum of torques. Okay, and because this is an equilibrium problem, we know that they're all equal to 0, but we need to figure out what the magnitudes of all the forces are that are going to balance to 0, right? Okay, so let's see what's going on in the X and then in the Y. So in the X direction, we just have H. We also have, so notice that these guys are at an angle here. So for the X direction, we also have this, T force that's at an angle, right? 50. So this would be our Y component, right? This would be T sine of 50, right? T sine of 50. But we want the cosine component, right? To get our X component. So if we're breaking it up, so we want to look for, actually, wait a minute.